Hi, folks. So, I love reading old seminal papers in computer science because they often derive from first principles what we completely take for granted today. One such admonition is the one against global variables. You'll recognize the familiar title, and that's because it is a nod to the Dijkstra paper, which talked about the go to statement being harmful. I did another video about that. Now, in this paper, they're talking not just about global variables, but they're making a much stronger claim, which is non local variables in general. And they claim that non local variables are a major factor in making programs difficult to understand. Their rough definition of a non-local variable is any variable which is accessed and modified over a relatively large span of program text, and they leave that vague and open to subjective interpretation. The reason why global variables are harmful is very similar to the reason why goto was not a good idea. So they start by recapping the reasons for why GoTo was a bad idea. And the basic argument is that the text of a program is static, but its execution is dynamic. And because it is much, much harder to reason about a dynamic execution, it will really help us understand a program if the mapping between the text of a program and its dynamic execution is relatively direct and easy to understand. When a program is written using structured statements such as if, case, and so on, it is relatively easy to determine how we got to any given point in a program. And from that, we can deduce all the assumptions that hold true when we are at that point in the execution of a program. And because the number of dynamic executions of a program can be really large, it is very hard to make a mental model of these executions. We make our lives easier by abstraction. And the way we abstract is by selectively ignoring some parts of the program and modeling only the parts that we think are relevant to the computation that we are looking at currently. Now, the authors try to formalize this notion of abstraction, supposing that S is a part of a program and P and P prime are propositions which hold before and after S. S, P to P prime means that P holds just before you execute S, and P prime holds immediately after you've executed S. This means that P prime must talk about the effect of all non-local variables modified during the execution of a program. And thus, the complexity of this abstraction is directly related to the number of non-local variables that we have used within this program segment. So what do non-local or global variables have to do with this? Just before you start executing the program segment, we need to check that the proposition P is valid. And the way we do that is by trying to ensure that the variables mentioned in that proposition actually have the values that we think they do. Now, in a straight line program, this is easy. You just scan backward until a use of that variable is found. Of course, straight line programs are very rare. No one writes straight line simple programs, which means you have to check backwards along all possible control paths. And the complexity of this task increases exponentially with how far back in distance the last previous use of each variable was along these control paths. And this is the central reason why scoping is the other half of structured programming. Just as structured programming helps you understand control flow, scope rules help in understanding the relevant values of variables. Just to make things concrete and provide examples, the authors go through some examples from ALGOL, which was a popular language at the time, one of the earliest structured programming languages. And they point out some issues with even having block structured scoping for variables. So the very first issue is side effects. What are side effects? Side effects are when a procedure makes changes to values of non-local variables. Why is this a problem? As the authors put it, untold confusion can result when the consequences of executing a procedure can't be determined simply by looking at the procedure itself. Another issue is the vulnerability associated with unintentionally shadowing a variable. What does this mean? Say you declare an integer x at an outer scope and then use it within an inner scope. And then somewhere in the middle of the program, you declare another x. Now, this use of x, which was originally intended for this outer x, gets shadowed by this use. What this essentially means is that if you want to use a variable at a level which is deeply nested, you must be aware of all the names used at all the intervening levels as well. These are complementary problems. When you have indiscriminate access, that means that the declarer of a variable has no control over who uses those variables. And when you have shadowing vulnerabilities, it means that the program itself has no control over which variables it's actually operating on. Now that the authors have pointed out a bunch of problems with global or non-local variables, where do we go from here? How do we solve this problem? Now, this problem is a little bit more complicated than the go-to problem because of two things. There is no one single construct whose elimination will solve this problem. And also, there's no familiar set of constructs which are more or less enough to solve this problem. So instead, the authors come up with a range of criteria which any solution to the non-local variable problem must satisfy. And this is a pretty strict set of criteria. Things like the default not extending the scope of a name to inner blocks. This is obviously not true of most modern languages because if you declare a variable in an outer block, it is accessible to all internal blocks. Another criteria is the right to access a name should be by mutual agreement between creator and accessor. This is true to some extent in terms of classes or modules, where external users can only access things that have been explicitly declared public. This is not so true within a procedure or within a method. So there you have it. That was why global variables are bad. I hope you enjoyed that, and I'll see you next time.